students. Now we want to complete the topic of differentiation on the last bit of application. This is application number 2. The first one was on linear motion, that is on getting the speed, that is velocity and acceleration. So today we want to look at getting maxima and minima. Mainly it applies in companies when they're calculating profit, minimizing the cost and maximizing profits. This is where it is applied. So we will look at it by looking at an example. Let's say a farmer has a wire which is 1800 meters and wants to fence a shamba which has one side which is a wall. So we have three sides. So the question is, find the dimension that will give maximum area. So our main agenda here is to find an expression for area. So the first thing we need to find something, remember algebra, an expression for this rectangle. Remember there are three sides. So we know area is given as length times width. So we can say let the width to be x. So this will be x and this will be x. Now that we have x, we need an expression in terms of x for the length. We know the total wire is 1800 meters. So for us to get the length, we know x is gone from this, another x is gone. So our length is going to be 1800 meters minus 2x. So that is our length. So we want the dimension that will give maximum area. So we need an expression for area. Area we have seen is length times width. So this is 1800 minus 2x. You multiply by the width, which is x. So our area will be 1800x minus 2x squared. So this is the expression for area. For us to get the dimension, we differentiate area with respect to x. So we get what we call dA dx. So this will be 1800 minus 4x. So this is the maxima, just the way we are finding the maximum, the turning point. So this is the maximum. So to find the point, just the way you are finding the point, you know at maxima or minima, the derivative is equivalent to 0. So we equate this to 0. So 1800 minus 4x is equals to 0. So 4x is equals to 1800. So our x will give us 450. So remember our x was our width. So our width is 450. Our length was 1800 minus 2x. So this is 1800 minus 2 into 450 to give us 900. So the dimension is going to be 450 by 900 meters. So this is 900 and this is 450. So the important thing is for you to come up with an expression which, remember, this has three variables: area, length and width. So we cannot differentiate directly because you could have just let length times width, but now we need two variables so that we can differentiate one with respect to the independent variable, which is x. So the most important thing in maxima and minima is for you to come up with an expression which you can differentiate and then equate the derivative to 0. then you can test if you're asked if it is a minimum or a maximum. Here you have already been told it is a maximum, so you don't need to test. So that is how we do calculate maxima and minima. So whatever you are told, for example, if you are told the surface area, maybe the surface area of a cylinder, maybe it is 432 centimeters squared. The surface area of a cylinder is 432 centimeters squared. Maybe you are told to find the dimension that will give, or rather find the dimension that will give maximum volume. So we know surface area of a cylinder is given as 2 pi r. Surface area of a cylinder, this is the curved surface, 2 pi r h plus pi r squared. This is how we get the surface area. So, but here we need an expression for h. We need an expression for h because we know volume is given as pi r squared height. So let's assume, so we need an expression for h. So in this case, our surface area is 432 is equals to 2 pi r h plus pi r squared. So we need to make h the subject. So our h will be 432 minus pi r squared over 2 pi r. So this is our h. Because they need maximum volume, because the question is find the maximum volume, you go to v now. So our v will be pi r squared. Then you substitute our h, which is 432 minus pi r squared all over 2 pi r. 2 pi r. You realize this pi will go with that pi. This r will go with one r. So our v will be 432 r minus pi r cubed. So we find, because they want maximum volume, we find dv dr. So our dv dr will be 432 minus 3 pi r squared. But we know that at maximum, this derivative is 0. dv dr is equals to 0. So 432 minus 3 pi r squared is equals to 0. So it will be 3 pi r squared is equals to 432. You can divide it, then you will be able to get your value of r, and that will be the radius that will give maximum volume. So what is important, you can see I've come up with two variables, v and r, and yet I was having three variables, v, r, and h. So you use the conditions given to come up with a condition of one unknown, then you substitute according to the question, and you will be able to get the answer. So for your assignment, do exercise 8.6 on KLB, and from number 1 to number 4. From there, you can go to your KMF, do the application of differentiation, that is 45.1. That will be the whole of differentiation. Do it little by little to perfect the areas where you don't understand, and where you don't understand, be free to ask through the various platforms that we have put forward, such as the Zoom, we'll be discussing every day at 6, and WhatsApp any other time. You can just contact me personally. I will be able to help accordingly. Thank you and have a blessed stay.